Guys, this is the last section that we're doing in Chapter 6. So tomorrow we're going to look at some review, and then on Friday is your test. I know you're excited. All right, honestly, I think you guys will probably do the best with this section because it's more solving. It's more algebraic based that you guys are like used to. Yeah, I think you guys will do better with this. All right, so how to solve with a radical in the problem. You all right, Jared? Okay. All right, you will get the radical, what do you think? By itself or alone. Yep. Get the radical by itself. All right, to get rid of the radical, do its opposite. For example, the opposite of a square root is to square both sides. You obviously wouldn't cube both sides, right? Square both sides of the equation. All right, then you will solve for x, just like any other normal equation. You must check your answer by plugging it in, because what could happen, you could have extraneous solutions. We've dealt with those before. If there's an x squared in the problem, you must set equal to 0. Then do what? Factor. And solve. Which again, you guys, we've done this before. That should come second nature to you at this point. All right? So the equations we're looking at today, they have radicals in them. They look a little frightening at first look. Okay? But first thing you want to do is isolate the radical. So what do you subtract 6. So we're going to have radical 3x minus 2 equals 4. All right, so get the radical by itself. And then what we really need to do is get rid of the radical, because I can't, right, I just need to square both sides then. So if I square both sides, what happens on this side? The radical goes away. It's just 3x minus 2. 4 squared is 16. And then we just solve. So 3x equals 18, x equals 6. Now, some of them get a little harder. Right, and or fractional exponents and roots, and we obviously get into more stuff. But guys, I would like you to at least do a little mental check on this for me to make sure that it worked out okay. All right, so if I would check my answer, if I plug this back in here, 3 times 6 is 18 minus 2, which is 16, square root of 16, plus 6, 10. So it does work. Okay, but just know that whenever you're like squaring both sides of an equation, sometimes you incorporate some extraneous solutions. So we need to always make sure we're checking for the extraneous. Okay? So how about you guys try these two on your own? Let's see how we do. Okay, here we go. So we had to subtract 2. So radical 2x plus 4 equals 8. Square both sides. So 2x plus 4 equals 64. 2x equals 60. X equals 30. Did we do a mental check to make sure it worked? If you plug this back in, 2 times 30 is 60. 64. Square root is 8 plus 2, 10. Just making sure it works. Nathan, you all right? Jared? Over here, subtract 3. So radical 3x minus 5 equals 5. Square both sides. So 3x minus 5 equals 25. So 3x equals 30. X equals 10. And then we double check it. We get 30 minus 5 is 25. Square root is 5 plus 3 is 8. So we know it works. How are we doing on the real basic ones? Good? All right. Is what? The 6 is not. Yes. All right, guys, take a look. Now, I've talked to you before about, did I ever tell you about my teacher? Yeah, the length of your radical makes a big deal, big difference. Because if you look at that problem up there, is the 6 under the radical or no? Is the 4 under the radical? Yes. So the length of your radical makes a huge difference. Teacher I used to teach with at Finley, he counted off every single time students' radicals weren't the right length. Okay? That's because it makes a difference in the problem. So here, to get this radical by itself, what do you move first? The 6. We have to subtract 6 first. So 24 minus 6, 18. Then what? Then we can divide by 3. And then we can square both sides. So 2x plus 4 equals 36. And then just solve. So 2x equals 32. So x equals 16. Do your little mental check on that. Make sure it actually worked. It does work. Just plugging it back in. So 2 times 16 is 32, plus 4 is 36. Square root of 36 is 6, times 3 is 18, plus 6, 24. You totally could. Question was, could you type that all in your calculator? Yes, you absolutely can. All right, so on the next one, what do you do first? Subtract 3. Good. After we subtract 3, square. So 5x minus 6 equals 16. Add 6. So x equals 22/5. You can leave it improper if you want. If you want to change it to mixed number, I don't care. Me personally, I'll probably leave it improper. Again, if you type this in and check this, some of you can do this in your head. Some of you don't do so well with fractions. If I plug it back in, what's 5 times 22/5? 22 minus 6. 16 square root of 16 is 4 plus 3 is 7. But again, could you type the whole thing in the calculator? Yeah, you could. But just, I'm trying to get you started here early on some easier ones, getting used to checking your work, okay? All right. Why are these different than the last ones? Good. Before, I only had just a number on the other side. Now we're looking, there's an x. But my goal is still to get the radical by itself. So on this first one, it already is. Yes, Alex?
So, is this going to go back to almost quadratic formula?
Yeah. If it doesn't factor. All right, so anytime you have an x squared, what do we have to do with it? Set it equal to 0. So x squared becomes minus 3x plus 2. I didn't want to move my x squared. Doesn't matter, or I can just look at it that way and deal with it. All right, does this factor? That factors. Yeah, x minus 2, x minus 1. So x equals 1 and 2. You should check these to make sure they still work, though. Do you have to check them both or just one? Both. Checking the first one. 3 times 2 is 3, minus 2 is 1, square root of 1 is 1, plug in 1, and it worked. Same thing with the 2. 3 times 2 is 6, minus 2 is 4, square root of 4 is 2.
Will you ever get a chance where you get 2 answers all in this order? Is that an extra?
It's coming. Just wait for it. All right, guys, what about the next one? You just do it. What do you do first? Add 3. Then what? Square both sides. So we get 11x plus 3 equals. Thank you. What did you just say? What's your mouth? Jeez. Guys, x plus 3 squared is actually x plus 3, x plus 3. So the profanity that flew out of Seth's mouth back there. What's your mouth? So we actually get x squared plus 6x plus 9. Sorry, I did more of that in my head.
Isn't there a trick where you just do?
Square both of them, multiply them together, and double it.
Yeah, that's what I thought.
Yeah. Yep. I don't ever teach the shortcuts because people use them wrong.
Is it only when it's only like the x is almost 1, right? And x squared.
No, it still works with any of them. If it's a quantity squared, it always works.
Yeah, okay, that's fine.
Yeah. All right, how do I finish solving that then? Good. Set it equal to 0. So x squared, I'm going to move the 11 over here. Minus 5x. Subtract the 3. Gives me a 6. And it's the dreaded 6-5 combo. X minus 3, x minus 2. So x equals 3 and 2. I do need to check that. Did you factor it different?
I think it might be.
Oh no, the 1 and 6 will get you a 5, but not getting me a positive 6. All right, 3 and 2 both do work. If I plug in a 3, it gives me 33 plus 3 is 36. Square root of 36, 6 minus 3 is 3. That's what I plugged in, a 3.
Oh, it has to equal 3.
Yeah, because I was plugging that in. Oh, yeah. No, whatever I was plugging in is still over there.
We're cute.
Oh! Oh! Yeah. Yeah, so this one is a cubed root. So we have to cube both sides.
It's -8 on the other side.
Yeah, so this is just going to be 5x plus 2 equals, that's -8. Wow, cubing things was hard, right?
Yeah.
So 5x equals -10, so x equals -2. All right, double check it, plug it back in. We're good. This stuff got real hard, right?
Yup, always.
Yeah, it's not too bad. So a little bit, but it's really not bad. So this one, try this one on your own. So subtract 3. Cubed root of x minus 7 equals 3. Cube both sides. So x minus 7 equals 27. Add 7. X equals 34. Did you check it? Does it work? Are you just lying?
34 minus 7.
Is
27.
cubed root of 27 plus 3 is 6. It works. All right. What? That's what I printed them. All right, what about number 8? What do you do first?
First you subtract.
You add 5.
Well, maybe I'm subtracting a negative.
Quit fighting. Then what? Divide by 2. Plus you? So equals 4. Then what? Square. Cube. So 8x equals 64. So x equals 8.
How'd you get 6?
Check your work. Where does yours differ? It's basic math, isn't it? Always is.
You do all this.
And it works. You were right. It works. Back one? Put it on. guys are smart enough, I can jump around a little bit with you guys. All right, if the equation has a fraction for an exponent, you must raise both sides of the equation to the blank of the fraction. Not denominator. Not root. Stop throwing out random words. That's it, the pizza. The pizza of the fraction.
The denominator, the reciprocal. The numerator.
Reciprocal.
I knew that. See,
I didn't read it. I was
I said that like 9 times.
It's even written right below there. If the denominator of the reciprocal, this is really important, guys. If the denominator of the reciprocal is blank, your resulting answer is plus minus.
Zero.
Denominator can't be 0.
Exactly.
So remember, when we take the even root of things, right? If we take the even root of things, it's plus minus. Because these problems are not going to have a radical in them to start with. We're introducing it into the problem, therefore we have plus minus. Then continue solving. You will have blank answers to check.
Zero. Yeah. That's what I want.
It's painful. Painful. All right. So, taking a look at all this. So the first thing, you still want to isolate all of that. So what should you do first on that first problem? Divide by 4. Yeah, you want to divide by 4.
Oh yeah, I did too.
No, you're going to have an ugly nightmare if you attempt to do that. You could, but it ain't going to end pretty. That's how to simplify a whole lot of operations in one big problem. It's not for solving. What's 64 divided by 4? It is 16.
Mine's that.
All right, guys, I need you to focus for me. All right, to get rid of this, we need to raise both of them to the reciprocal of that fraction, to the 3/2 power. 3 seconds. Now I want to explain why. I want you to know why that is. I'm trying to get this exponent to go away, right? That way I can actually do something to solve this for x. So what is 2/3 times 3/2? It's 1. If the exponent's 1, I don't really need it. 2 times 3 is 6. 3 times 2 is 6. 6/6 is 1. So that will give me an exponent of 1, which is what I want for it to go away. Okay. So for this one, we end up with just x minus 3. And then what is 16 to the 3/2 power? It is 64. No, I just a fluke, for that's how the problem started. That's an exponent. That's an exponent. Jared? Already? I haven't done much. Yeah, we're doing it together. I'm not really sure what you did. Yeah, guys, this is an exponent. Some of you have Jared especially, has a really bad habit of multiplying this by the number. It's an exponent. So really this means the square root. What's the square root of 16? Cubed. What's 4 cubed? 64. Is my answer plus minus? The denominator of the reciprocal is even. This is plus minus. That's the answer from that. Right? I know. And then you have to add 3. What's 3 plus 64? What's 3 minus 64? Negative 61. Should you check that? Yeah, might be a good idea to check that. Could you just type it in your calculator? Yeah, honestly, for most of you, that's probably going to be the way to go. Type it in, see what you get. So somebody said 67 works? How about negative 61? You tell me. Did anyone check negative 61?
The negative 64
It says domain error.
What are you guys
It's
typing in?
extraneous.
What are you guys typing in? That's probably the real question. All right, let's check and see what you guys are typing in. So, what's negative 61 minus 3? So make sure negative 64 is in parentheses. And you're raising that to the 2/3 power.
It says domain error.
That's 16. Yeah, what are you typing in? Here. What do you do first? Subtract 7. But I don't know why. Divide by 2. Thank you. Now, guys, let me talk to you about a couple things here. Like, this is on a weird form, right? We have a exponent under my radical, and I got a different root. What should I do with that? Change it to the other form. Because this is x plus 2 to what? To the 5/3 power. Now I can take care of both numbers all in one shot. Well, I'm supposed to. Technically, that is the correct math way to do that. Will I have a plus minus on my answer? No, my denominator is odd. So what do I get on the left side? It's just x plus 2. And then what is 32 to the 3/5 power? 8. 3 divided by 5. So type in 32. Not times 3/5. 32 to the 3/5 power. Yeah, that's an exponent. Stop pulling a Jared. So x equals 6. He did it in 2 steps. That's fine.
Oh yeah, that's what
Daniel likes to do things the hard way.
got rid of the
You did the same thing Daniel did. It still works. Paige did the same thing you did. Once we isolated this, right, I just subtracted 7 divided by 2 here. I switched this from radical form to exponential form. 2 days ago, we went back and forth where I did some problems, you did some problems. I did some problems, you did some problems. Remember that day in class? 5/3. Remember the roots grow underground? All right, he's back. All right, how about the next one? What do you? Yeah, we did. You weren't paying attention. What do we do next on this one? Add 4. Then what? There's no radical, but is there really a radical? Yeah, there is. Divide by 3. Where is it? We got a 5th root. Then what?
Exponential value of
Thank you for changing that wording, because I was really going to tell you no. I'm not multiplying both sides. I'm raising both sides to the 5/3 power. Plus or minus, yes or no? No. So x plus 5 equals, that is correct.
Yeah, how'd you get that? Yeah, I typed it in my calculator. I got 240.
I got 20.3, yeah. 27 times 3. I have 3,700.
Oh, wait. You're right. Yes, you did. Cubed root of 27 is 3. 3 to the 5th power is 243.
Yeah.
Square.
No, I forgot to put, and then I got exponential now. I put 27.4
Gotcha. So then x equals? I'm not used to seeing numbers that big. Did that work? I'm going to go with yeah. Anyone confirm that it works? I mean, I got that. Really?
Maybe it was the negative that was throwing it off.
Must have been. That's weird. I'm very confused on why that calculator's doing that.
It's Jared's calculator. It does the impossible.
It's like Jared.
It just factored the equation and everything.
All right. It must have been negative. All right, guys, let's kind of, you're going to have a part 1 assignment, 10 to 22 even. But I want to try to finish this section. So really the focus of the second part is really not anything different, except what happens is you do get some extraneous ones. So the first part, we didn't deal with any extraneous yet, right? Everything's always worked. All right, so it's necessary to check every solution. Some solutions you'll find will not satisfy the original radical equation. Solutions that do not check out are called extraneous. All right, so we've talked about extraneous solutions before. We're familiar with them, yes? Sometimes they show up. So really this second part is not new stuff, it's just some of them are extraneous. So, first problem, what do you want to do first? Add 4. We didn't do the last one on the last notes, if that's what you're questioning. From the first section, I didn't do the last problem. I skipped it. Oh, wow. Let's finish this one and we'll go back and we'll look at it. What do I do to this? Square both sides.
I was trying to think of a word.
The reciprocal of 1/2 is 2. Plus minus, yes or no? No, because that's the denominator of the reciprocal. It's 1. So we get x plus 6 equals x squared plus 8x plus 16. That would do it. What do you do next? Like terms, set equal to 0. So x squared plus 7x plus 10. Does that factor? Mm-hmm. X plus 2, x plus 5. So x equals, and we check. On which one? Yeah, which one? So if I check, -2, we can do this one in our head. What's -2 plus 6? 4. This means square root. What's the square root of 4? 2. 2 minus 4 is -2. -2, that one works. If I plug in -5, -5 plus 1 is 1. Square root of 1 is 1. Plus minus 4 is -3.
Wait, you just said 1.
-5 plus 6 is,
You said -5 plus 1, okay.
so Did I say +1? Oh, my bad if I did. My brain was working faster than my mouth was. All right. But yeah, the -5 is the one that's extraneous in this case. It doesn't work. Look at that. That's the whole second part that's new. Oh, they're extraneous. Let's go back to the one that freaked them out. The last one that up here that I skipped. For whatever reason, this freaked people out. I don't know why. Let's go back to this one. So you should have added 4, right? Guys, let's go through it. We'll find out what happened. Add 4. 250. Divide by 2. You guys cool if I switch this at the same time? 125? You guys cool with that? Raise it to its reciprocal, which is 2/3, plus or minus? Yes or no? No. Denominator's not even. So we get x plus 2 equals? What's the cube root of 125? 5 squared, so this is 25. So then x equals 23. Why was this so bad? 3/2. This is 3 over 2. The root is 2. You just messed up. Okay. I know I'm like, I skipped that one because I thought it was just like the rest. But then you guys like. I'm like, what's going on? Yeah. All right, here we go. Take a look at the next one, guys. What do we do first? Add 4. So radical 11x plus 3 equals x plus 4. I'm okay. Then what? Square both sides. So we get 11x plus 3 equals. Good. He is, because that was pretty fast. Then what? I don't know. So x squared minus 3x. We haven't had this.
You guys kidding me? We can quadratic formula this. Oh no! What are you saying that for, Jared? You like doing it.
Oh, isn't this fun? What the? I forget. Negative b plus or minus square root b squared minus 4 times a times c all over 2a. 3 plus or minus square root 9 minus 52 minus 51 negative. Is that right? How about you guys? My brain hurts today. Is that right? Negative 43 all over 2. So x equals 3 plus or minus I radical 43 all over 2. So how are we feeling about that?
That was pretty radical.
How do you check that?
Plug it in. Alex, stop moving.
Can we have imaginary answers for this?
No.
There's no solution. Yeah, we can't plug that back in and have that work. That's just insane. Wasn't it fun though? Brings back old times, good memories. What happens when there's a radical on both sides?
You can square both sides.
You just square both sides. Hey guys, focus. Square both sides. So what do we get? 2x minus 7 equals x. So x equals 7. That started out looking way harder, right? Does it work? Because if you plug this in, 2 times 7 is 14 minus 7. So I get radical 7 equals radical 7. Yeah, it does. Okay, what about the next one up there? What do I do with that?
Yeah, you can square them both. Because 1/2 is radical.
But they're on the same side of the.
And you can just, but what happens when you square?
What'd you say?
I just minus to the subtractive balance. Do the thing you already taught us. 3x. Wait, why can't it be 5x plus 7 equals 2x minus 5?
Guys, it's a minus this, so I added this. For technical terms there. You can move a whole chunk to the other side. That's okay. Yes. Minus this. What's the opposite of minusing this? Adding this. I added this to the other side. And then you can just square both sides. Sure. There you go. So we get 5x plus 7 equals 2x minus 5. Hmm? Mm-mm. Um, it's already like a big group. So in essence, I could technically replace a big chunk of something with an x. If I move the minus x to the other side, it becomes plus x. It doesn't change whatever the x is. No, we can't do that. Because right now, these are being held captive by those exponents of half.
But they're the same as
Doesn't matter.
You can't just.
Good try, though. Yeah, can't do that. So, 3x equals negative 12. X equals negative 4. Hey, guys, stop speaking. Does it work? Did you check? Or are you just telling me yes to get me to stop talking? I don't know, but I'm about over it. You're the only one who can tell. Does negative 4 work? Did you try it? Okay, this is where you actually grab your calculator, you type it in, and you tell me, does it work? Yes or no? Are we typing it in all as one piece or no? That'd be the wise way to go. Because you should get what for an answer? You should get 0 if you type it all in. You got a what? An error. All right. Yeah. How are we feeling about all this? It's a lot of the same. This? This? Yes, yes. Guys, let's take a look at this one. Thank you. I forgot about that one. I forgot I stuck that one on there. All right, guys, we're going to look at this one only because what happened here that's kind of frightening. Your fractions aren't the same. So first thing we want to do is take this and move it to the other side. So we're going to have 11x plus 45 to the 1/4 equals x plus 5 to the 1/2. You guys with me so far? All I did was just move it over to the other side. So normally, I would raise it to its reciprocal, but I can't raise one side to the 4th power and one side to the 2nd power. Yes. You're going to have to raise it to whatever power eliminates your fractions entirely. common denominator. Because one's a 2 and one's a 3, I'd have to go to 6. You know what I mean? So for here, I'm going to go to the 4th. Let's kind of see what happens here. On this side, you're left with just 11x plus 45. Very nice. The other side's going to be x plus 5 squared. Real quick, what's 1/2 times 4 is 2. So it left me with an exponent still. So then we actually have to see what that is. It's x squared plus 10x plus 25. Yeah, remember that's x plus 5, x plus 5. You have to distribute all that. Right, so then we get 0 equals x squared minus x minus 20. It factors. Yeah, that actually factors. X minus 5, x plus 4. So then x equals 5 and negative 4.
44 plus 45.
Feel like we should check that? Yeah, I probably would. So if we check that, again, grab the calculator. Let's type it in, see what happens.